I'm Patrick Bailey with IQlist.com. Today is April 9th, 2022, and in this video I'll be going over a 3D printed GoPro monitor mount I made. Okay, now you may have noticed on my intro I was at a severe angle and it was all off. And that was just kind of exaggerating what I have had happen for years now because I'm too lazy to... I was too lazy just to fix it. So I kind of like doing a GoPro for the initial... Well, backing up, I used to use the GoPro all the time because my computer a couple of years ago was not fast enough to use the... to kind of keep sync with everything when you're kind of recording everything and recording the webcam and all that. It wouldn't work very well. So I just filmed with a GoPro and then I kind of synchronized it all after the fact. But now I got a better computer, my web camera works pretty well, but I still kind of like doing, I'm thinking of keeping doing the intro with the GoPro because I get a wider angle and you can see the disaster that is my office, and someday it's going to look cooler. I'm changing everything around, but it's going to take a long time. But with this, I use this little guy. And whenever I use this little guy, the problem I always had is it's loose, it's lanky, I kind of get it fit and do as best I could and control it. And I always end up with an angle, and I have to readjust the angle after the fact, you know. So for years I've been like, let me go make something simpler. But I was too lazy to, because I kept trying to overthink the process. So I was trying to think of an example of this, like I have a camera right here, and you got a little hinge and adjust, so you can kind of adjust it to anything you want. But then I was like, that's nice, a little more complicated, maybe I could still do that. But why? I only have this one thing and I got a 3D printer. Why don't I just make a one-use thing that may not apply to everybody, but it'll apply to me? So that's when I did this. It took me a couple of iterations to kind of get the angle correct, because here I'm set. I'm not going to change anything with this as it is, as the printout, but I was trying to make something nice to squeeze it, but it turned out if you get it close enough, you know, you can just press it in there. It'll hold just fine, because we're not going mountain biking with this. It's just going to hold on the screen, and then boom, there we go. We got a little lip on the end to kind of hang over there, and there you go. And now I can just put it on there real quick, and life is good. And I like it. I put it up on well, now they changed their name to, it was Prusa Printers, now it's printables.com. But I'll go over this because if you happen to have the same monitor and a GoPro, it'll just work. But if you have a different monitor, it's on Openscad, and I'll kind of show how I did it and how you can adjust to what you did. And I think in this video I'll also kind of do a combination video and go in detail on how to recreate the entire thing in Openscad. So with that, let's go over a lot of the details. Okay, let me show you some links and kind of go over some details. So I have this up on, well, it was Prusa Printers, and I guess now they've rebranded it Printables to kind of just say it's not just for Prusa anymore, right? Not that it ever was. But if you go over here, I'll put a link in here. I put it up here with the file and the Openscad. So you can get the STL file or the Openscad to adjust it. But also for convenience for some of us geeky programmers, I did stick it out here as a gist on GitHub, so you can just go download the code directly there. So with that, usually at this point I go over the numbers, but this one's kind of boring. I mean, it's a simple design, so I didn't bother recording a little, animate a stop motion thing for it. But just the rough numbers, it's really lightweight, 0.16 kilograms. It's roughly 2 hours to print. And so roughly with all that, it's about 33 cents to print. It's not much time. So it's under 50 cents and you can get this whole thing. So it's not an exciting print, but it's a very useful one for me. But now let's go on and just kind of show how the Openscad code as is works. So if you have this, and you happen to have a GoPro, I think I have a 5 here. I kind of forget. GoPro Hero. I think it's a 5. It's been a while. And I think all their dimensions are the same. So I think if you have a GoPro, I think, these upright red verticals are going to work just fine for you. But what might not work for you is the angle. You have a different monitor. So if you print this out and stick it on your monitor, you're probably going to not have the right angle that you want. So what I would suggest is here we can go down here. Boom, boom, boom. We have how much you can extrude. I'm going to put a note here. I have it at 30. We'll take it down just to 3. Boom. So I suggest making a real thin one at first to kind of see what the angle looks like and see if it works on your monitor. And then from there you can make a bunch of other small ones to fiddle with the angle. So you can go down here and say, well, the thickness, that shouldn't matter too much. That's how thick you want to make these guys. If you're going to make them thicker, go nuts. I don't really see a reason. But I did code it in such a way that it adjusts for the thickness. So if you change the thickness, the distance between these two should still remain the same, I hope. Monitor height, let's see. I'll just put a note here for 12. And I think this is the adjustment right here. So if I make that a 5, you should see, boom, it changes to 5. If you need to make it bigger for your monitor, your lip's a little different, tweak it accordingly. Although that's probably going to work for most people, even if you have a bigger lip, it's probably not much of an issue. The monitor depth, you see that 3. Boom, boom, we'll make it a 6. Well, let me make a note there, make it a 6. That's how far that lip goes in. So you can adjust that to how you want. Now another thing is that top length, you may want to adjust that too, depending on how big or thick your monitor is. But let's go make this 30 for whatever reason. Boom. Very, very narrow. Or 100, right? Boom. Maybe you got a really thick monitor for some reason. But I have a feeling that you're probably not going to need, you may need to adjust this height, maybe, but I bet you this will probably work for most people. What you're going to want to adjust is this length and this angle. So you have the support angle. I got 55 right here. So what I can do is I can come down here and say, 30. And it's going to make that angle much more steep. Let me just say 35. But also the support length. So you can tweak those a lot to kind of figure out what's going to work for your monitor. And I would suggest, try the first one. Make the thickness 3. Try the first one. Then you can kind of figure out what you want to adjust. Because I think between those two angles, you can kind of figure out something that's going to work for you. And also, really, you probably just leave it at 55 and just adjust the length. And that'll probably do it for what you need. And, just in case, maybe I'm wrong about the GoPro width, or you have a different kind of camera maybe, you can change that too. Boom, make those wider. Okay. And then we have the support height. Right now I have it 12, but you could make those longer if you wanted to. I don't know why. But there's, I doubt many people have the same monitor I have. I have a 27-inch Dell. I forget which model it is. If I can find it, I'll put it in the show notes. It's been a while since I purchased it. But without too many tweaks, I think you can get this to work on most monitors just fine if you want to mount a GoPro up there and just stick it like I do and not have it connect to anything. Now, it's not good enough where you're going to, it's not like attaching it to a bike mount where it's going to hold steady. But again, you're in your office. You're not going to be rocking your computer, so I don't really see an issue with this just laying gently on there. So, boom, boom, boom. There's that. So now let me take some time and recreate this Openscad code that I already made to kind of go over and show how it's done in case you want to do something similar. Because this is actually a pretty simple design. I think it works well. But with that, let's go in detail for those who want to go in detail. Okay, let's get going on recreating this. So as you can see on the original one, I have really just two pieces to this. I have the lower support and the actual what I'm calling the GoPro mount. So we'll start making those modules. So first, we'll just start with the support. So I've kind of got a blank sheet. I kind of say this FN200, that's the level of detail. The higher that is, the slower it will render, but you get more detail. The lower it is, the quicker you'll render, but you get less detail. So sometimes you might want to use that if your computer's going a little slow. So we'll come down here and we'll make a module first. Now, if I haven't pointed out before, there's a couple good reasons to make modules. One is you could reuse it. In this case, I'm not going to reuse it, but it's also a good case if you're not going to reuse the code, you have the code separated out and say, this module only covers the support. So if you have an issue with the support, you can go to that one and fix it. So we'll call this one support. And right now we won't put anything in it. And we'll just say, boom. And well, we won't pass any variables into it. So we'll just say a circle. And we'll say, am I using radius? Boom, boom, boom. Let's review what I was doing over here. No, I'm using diameter. So a circle, gives you a little hint. If you normally put something in there, it'll be a radius. So I can put a 10 in there like that. And, well, of course, now that I've done that, nothing's going to work because the modules don't do anything unless you actually call them. So I'll come up here and actually use that one. And I'll say support. And there's that. Now that's the radius, and you could just see how it defaults to radius, or I can say R equals 10 and get the same effect, or I can say diameter. If you really want to use diameter, which I want to in this case, you can just use the diameter. So we'll start with that, and we'll go boom, boom, boom. What do I want to do? Circle. That's my thickness. So we'll start up here. We'll start with our first variables, and we'll do extrude, and we'll make it 3 because we're going to start small, and we'll eventually make it 30, and then we'll also say thickness, and we'll say 5. Boom. That's how thick this guy's going to be. So what we'll do is we'll say linear extrude, boom, linear extrude, and we'll use that extrude number. Boom, 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 boom. Okay. And now you'll see it extrudes 3, but if we made it 30, it extrude 30. But we'll keep it 3 right now because we'll want it for testing if we actually want to do it yourself. Okay, so now that support, we're actually going to pass in that thickness, and we'll come down here and actually accept a variable and call it thickness. And then we'll replace that 10 with the variable that we're passing in. Okay, thickness, boom. Now I come up here, change that, and you'll see it changes. So far so good. So now what we're going to do is we can see what I'm going to use hulls. Well, let me just show you a hull. So here we can make this circle, and we can translate it. So translate just means you're going to move this around in the X, Y, Z. And in this case, I don't want to move it in the Z. I just want to move it in the X and Y. And so I'll say, let me move this 10. I'll move this 10 and 10, 10, 10, and 0. And then I'll make another one. Boom. And we'll say that one is 10, and we'll say it's 0. We'll just make it 0. We'll make it 0, 0. Why not? Boom. Now I got those two. Now if I want to, I can connect them with a hull. I can say hull, and it's going to say everything in here I'm going to connect up. Boom, boom. And it makes that nice connection. It's really nice. It's really convenient. But you got to think about that, what the results are, because I can come down here and make another one, and I could say negative 10, 10. Boom. And you get that, which might be what you want. But if you want to connect all of them, you may have to do something a little... If you want it to be connect, you may have to do something different, where you make 2 hulls. So I'll just repeat this again. So I'll say hull, boom, and I'll take that last one and say that, and then I can get something like this. So I have 2 hulls. There's that hull and there's that hull if I want an effect like that. So you got to think that through on what you want to do. Okay, so let me go look at what I have over here, because over here you can see I could have a hull here, a hull here, a hull here, and a hull all the way down here. But there's a lot of variables to pass in, right? So we'll start here and just make that one. So we'll call that one, what do we want? That monitor height. There we go. So that's our monitor height. And we'll say, what did I say? I said 12. So now we'll pass in that monitor height. Boom, monitor height. Boom, there you go. And what we're going to do, let's see. And also we want to color it. So I'll come down here and you can say color. I like doing these colors. They just help you distinguish things while you're rendering. But when you're done, the colors go away. So, boom, we're blue when we're not working. Why aren't you blue? Okay, someone didn't like about being blue. Okay, so we got monitor height, monitor height. Okay, someone's not happy about that. Oh, I'm being silly. Okay, here's a fun thing about understanding the code. Okay, so it is blue, but it isn't blue, just to make your life more confused. If I come down here and I remove that linear extrude, that's blue. And even though it looks like it has a thickness, it really is not. It's actually flat. So right now that's flat, but I can see it as blue. So I really don't want to make it blue there. I want to make it blue up here. So I'd want to come up here and say color, blue, because it kind of loses that information of being that color on the flatness when you extrude it. So I'll make that blue, and I do not need to make it blue here. Womp, womp. There we go. So now we are, oh, put it in the wrong place. Needs to be here. There we go. Perfect. Now we got a blue. Okay, so now we want to do that top length. So we'll come down here and we'll take that first one. We'll take that 0, 0 position. Boom. Let's see, what do we do? We had, yeah, we had the 0, 0 permission. That works just fine. But from that 0, 0, what we want to do is go down. And depending on what we want to do, here's where your logic comes into place. Let's see with my brain. Now, for those who are watching this, sometimes this can be a little long, drawn-out period because I'm trying to think things through and try to show in real life how things take some difficulty to work through. So some of this is not actually rehearsed, so there can be, but it's a video. You can skip around. I mean, you're watching YouTube. You can skip to where you want. If you see me stuck, I'm going to cut out a lot of sections. If I'm just sitting here hemming and hawing for 5 minutes, I'm going to cut that out. But sometimes it's nice to see someone have an aha moment, but it's YouTube. You can skip around to where you want. Okay, so we've got that. Now, the other guys I want to translate. I want to translate him down so in the Y. So we'll say negative monitor height, right? Boom, and we'll see that go down, and I'll remove this other hole. I don't need that right now. And so there I go. But there is an issue because that is that point to that point, which may be what you want. But depending on how you're measuring things, what I really want to do is I want that when I extend this out and I extend the other guy out, I want that monitor height to be that lip right there. So, well, let me show. Let me make this another hole. And I'll say, and then over here we'll say 10. Let's see if that works. So there's that bottom, and let me go make a top. So these aren't going to be correct. So we'll come up here and we'll say, and we'll give ourselves some hints here. We'll call this, we'll call this monitor height, monitor thickness, and we'll come over here and make another one and call it monitor length or something. Monitor length. Okay, and that one will be 0, 0, and we'll go 0. We'll just call it 100 for now. Oh, no. 100, 0. There we go. Okay, so there's that basic idea, but there's a problem here. If I really want to go measure the lip on my monitor, what I have said here is I say this is 12. What if I want this exactly to be 12? I got a problem because 12 is actually from the center of here to the center of here. It's not going to fit if you're measuring precisely. So what I'd rather have 12 be exactly what that is. So what I got to do is I got to add that thickness to that, because here I got to add that half thickness here and the half thickness here, which comes out to the thickness. So what I'll say down here is I'll say minus the thickness. Let's see if that's what I wrote. Yep, that's what I wrote on my other guy. Cool. So we'll come down here and we'll say minus the thickness. Oh, but then I need to pass in the thickness. Oh, I already did. Never mind. Okay. And we should see that pop. Okay, that one popped, but I forgot to do that one. Boom. So now that thickness is exactly what I want, right? Now the next thing, how far do we want to stick this in for the lip? Now the lip, similar thing. So I want to say monitor depth equals 3. Now there's a question of how you want to define monitor depth. Monitor depth. I'll pass that variable in. There we go. And we come down here. That's how we want to stick that in. Monitor depth. We'll just stick that in, that 3. But I think, what did I want to do? What did I do? Nope, I just straight up said monitor depth. Okay. I was a little... That can be a little deceptive, and that could probably be improved, because that monitor depth is between there and there, but I still got this extra 5. A little deceptive, because I probably should have said, this is right, I probably should have changed it. If I really want that depth to be that thick, what I really want to do is change that monitor depth minus the thickness, right? And so we should see that kind of end up going the other way. So in this case, I should be, what, an 8? Arguably a better way to do that, so compared to what I did before, but it's just a little nub, so maybe that's being a little over anal. So the next thing is the the length. And the length is pretty just the top length. What did I say? Top length. Boom. Top length equals 65. That's what I did before. And so I'll say top length. Top length. And then we come down here and we got this guy down here, and rather than 100 we'd say top length. And then what did I do? Did I actually do, I bet you I did the same thing on the hull. Yep, I just said top length, didn't I? Yep, I just said top length, which is okay. It depends on how you think, because the top, I think that's actually okay and accurate, because the top length would be from here all the way to here. But I need to add 5, because I need to subtract 5, because, yeah, I didn't quite do that right either. So what I really want to do is I want to subtract that thickness again. So here's an example where my code that I put out there, once you review it, could have been better, right? Because that top length should be from this guy all the way to this guy. And in fact, my top length, there's 5 more added to it. So let me subtract that thickness, which is going to subtract a little bit, but I'll add it back here. So potato, but it's more accurate on how you want to design things. Okay, so there we go. And then the last thing we got to do is we want to do the angle, right? So the angle gets really fun. So we'll come down here and we'll say, okay, we're gonna make a support angle, boom. And a similar thing, we're gonna do the hulls. So we'll copy this guy, boom, boom, and we'll use that first one because we want to connect at the very end, right? So that should work. And right now I'll just make a strange one. I'll say, I'll say 50, -10, just to make something, okay? But that's not what we really want to do. We just want to angle it. So let's see, what did I do here? Hull. Okay, circle, translate. A lot of sines and cosines, right? Which could have been done better. Maybe? Okay, so we got a support angle. Boom, boom, boom. We got the support angle. Support angle equals 55. Boom, and support length equals 40. Okay. And we'll pass those in. Support angle. If I can learn how to spell. Support length. And then we'll pass those in. Support angle. Support length. Now we got to do some sines and cosines. So that's accurate. It looks like, what did I do last? I'm trying to stare at what I did last time. I did some funky stuff. There's a couple of choices on how you want to do this. So it looks like I just transposed it to the correct location. So that's another option, probably a simpler option. So I think I'll go with how I did it before. So rather than do it this way and do that, figure out the sines and cosines, what I'll start, I'll start it and then I'll move it. So what we'll do is we'll do it at the 0 point. So we'll figure out the angle first, right? So we'll just say that just so it appears somewhere. Oh. Syntax error. Oh, forgot a comma there. Boom. Okay, so what I'm going to do, as you see over here, let me make it a little more severe. So I'm making this one a circle right there, and a circle all the way down here, and I'll figure out the angle. Then I'll just shift the whole thing over. So we'll have 0, 0, 0, which works just fine. And then we will do, in fact, I don't need to, there's no reason to translate that to 0, 0, 0. I can just do that because it's already at 0, 0, 0. Boom. But now this translate, we're going to do some sines and cosines. So we'll do the x, y, and z. And so we'll just do, let's see, what do I do? Negative cosine of the support angle, boom, times the support length, boom. Let's just start simple, do that one. There we go. And then we'll say negative sine of the support angle times the support length. Boom. So now, hopefully I can come up here and say, you know what, I don't want that angle to be 55, I want it to be 75, and we should see it adjust. Perfect. I don't want it to be 40, I want it to be 140. Cool, so that, so far, so good. So we go back to 40, there we go. But now we need to translate this whole thing. So now we've made that whole thing, we've made the whole hull. We'll translate the entire thing. Boom, boom. We really need, oh, come on. Shift it, there we go. Boom, boom. And so we'll say 0, 0, 0, just to get it started. We don't need to change it in the y or the z, just the x. So we need to change it the top length. The top length, right? Minus the thickness. Because it needs to match up with that guy. And we should have, look at that. Boom, we're done. So there's our basic support. And now we got everything we need. We can adjust it. We can go make it 30. If it doesn't work for you, you can, it's easy peasy fix. Okay, so the next thing we got to do, now that we have that going, is we need to get the GoPro holder. So I'll come down here and I'll say color, boom, red, boom, boom, and we'll call it, well, we need a linear extrude, right? Linear extrude, and we'll make another module. We'll call it GoPro holder. And for the moment, we won't put anything in it. We won't put any variables in it. We'll come down here and we'll say module GoPro holder. Nothing in there. Boom, boom. And we'll just make a circle. Circle, we'll make it big. Diameter equals 20. Boom. And it doesn't like what I did. I spelled GoPro wrong, so I couldn't find it. Change the name. Boom, there we go. So now we've got something there. So I got the GoPro holder, and what I want to do is we got the thickness. We're still using the same thickness, so we'll pass in the thickness, right? Thickness. And we'll just use this as an example. Of course, once I do this, it'll kind of disappear. So it's the same size right there, just kind of meshed in there. And then what we want to do, we can easily do the last one over here, because the last one will be at the very edge, right? So that's an easy one to do. So we'll come down here and we'll say, we'll do the two circles. So we'll say translate, boom, boom. Well, there's a couple things we can do. We can translate the translate. Okay, we'll translate the translate. Okay, so we get that one circle, and then we'll make another circle, but we'll translate that circle. So we'll kind of do what we did with that angle. So we'll start at position 0, and then we'll move it after the fact. So come down here, and I'll say the same circle. Boom. But now we're going to say we want to, what did I call it? There is GoPro, oh, there we go. GoPro support height. I called it GoPro support height, so we'll use that guy. We'll pass that in as a variable. And what we'll do is that's the height, so X will be fine. We'll just call that that. And so now I should see a little guy like that. Perfect. And we'll make a hull of that. Boom. Now I want to shift that all the way to the edge, right? So that's where we use this translate that we kind of saved up here. Boom. Boom, boom. And I can actually go down and copy what we use in the angle one, that guy right there, top length minus thickness, and it should pop over to the side, right? Boom. Perfect. So that should be kind of what I'm seeing over here, right? Yay. I think we're getting good so far. But now we want to make one more, and we want to make that one more exactly the GoPro width, so you can adjust it, right? So come up here and we'll say, call it GoPro width, and I'll pass that guy in. Boom, 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 boom. And I'll kind of copy and paste this simple one, because, well, let's just copy the whole thing, because it's going to be the same thing, it's just where we translate it, right? So I'll make it 0, 0, 0, just so we can see, right? So 0, 0. So what we want to do is I will copy this, boom, to get it at that very edge. So now they're right on top of each other. Boom. But then I need to make an adjustment to pull it back. And so I can say minus GoPro width. Boom. But then we have a problem, because that is the distance to here, so we need to add that thickness in, but we're going the negative direction, so we'll minus the thickness, and it should nudge it over just a little bit. Boom. And so now that should be the distance between that one. And if I leave that guy up and kind of bring this guy in, and you zoom in a little bit, and you can see we got the same result. So perfect. Only last thing to do is come up here and change that extrude from 3 to 30, and I've remade my code. And I've made a couple of fixes, like with this nub and the length here, but only two things that this is a very simple model, and if you're a coder, if you go back on your code, you always can make improvements. It worked. The code was fine. It worked just fine, but there were some things to simplify it, and even something this simple, there's not much to it. But I even found 2 things that could be improved pretty easily. So there you go. And if I go here now, I can render it. I should see all this wonderful stuff. Boom. So there you go. That's how you build it. Pretty simple. There you go. Okay. So now let's wrap this up with a reminder that 3D printing is an engineering venture that you're on. You can develop your skills and knowledge and take this in so many ways. You can make a business out of this. You can teach others. You can make amazing designs. So, engineer on. Well, that was a simple print, and a useful one for my work. It's funny how we put off fixing something for so long, then once we do fix it, we're like, wow, why did I not do that earlier? On another note, I'm working on a corgi crossing fridge magnet. I know I'm going corgi crazy, but it could be used for other creatures that need to cross streets.